number 9, they say, you know, that the graph shows the velocity graph of a particle, and they say to draw the particle's acceleration graph for the interval from 0 second to 4 seconds. So basically, they want, you know, to obtain the acceleration graph from 0 to 4 seconds. So what we know that acceleration is the slope, right, of the graph of the velocity. So I will draw here my graph of acceleration. This will be time. This will be acceleration in meters per second square. And this is time in seconds, right? Now, from 0 to 2, what is the acceleration that we have in this case? We know that the acceleration from t equals 0 second to t equals 2 seconds is equal to delta v over delta t, right? So at t equals 2 seconds, we have a velocity of 3 meters per second. Minus, at t equal 2 seconds, we have a velocity of 1 meter per second. And this is occurring, you know, in 2 seconds. So we get 2 meters per second over 2 seconds. This is 1 meter per second square. So from 0 to 2, I have this as graph of acceleration. This value here is 1 meter per second square. Okay. Now, from 2 to 4, what is going on? The slope of this line is 0, so the velocity was constant. So we have now that from 2 to 4, we're going to have a graph like this. So my acceleration from 2 to 4 would be 0. I don't have to do any calculation, you know, because I know that I have constant velocity. So my graph here of acceleration is 0 because the slope of the horizontal line is 0. So I got my graph of acceleration based on the graph that I had for the velocity of the particle. Okay. So any question? No questions?
No questions, Professor.
We have some problem for you to solve, you know, but let us solve some more. And then at the end, I will give you some problems that involve some operations, you know, involving calculus. I will give you a chance, you know, to work by yourself for a little bit on those problems, right? So question 19. Question 19, they say that a Porsche can go from 0 to 60 miles per hour in 2.5 seconds. Assume the acceleration is constant. So they say, what is the magnitude of the acceleration? I have a first issue here. There is with the units. Why? Because as you see, they give you the interval of velocity, you know, from 0 to 60 miles per hour. But later they give you the time in seconds, right? They ask you the magnitude of the acceleration. We are working in the International Systems of Units. The acceleration in the International Systems of Units is expressed in meters per second square, right? So the first I have to do is to convert those 60 miles per hour, right, into meters per second. So you can do the conversion, okay? You can convert 10 miles to meters. You can convert the hours into seconds. In the last class, I gave you, some of those conversion factors. You can find also, more of those conversions in your textbook or on the internet, right? So if we convert the 60 miles per hour into meters per second, we get that 60 miles per hour is approximately, 27 meters per second. It's really 26.8 and more digits, right? So we're going to approximate this to 27 meters per second. So if I know now that I am going from 0 to 27 meters per second, because now instead of 60, I will be working with 27 meters per second velocity. I say that acceleration, what is delta V over delta T, what is V final minus V initial over delta T. So it's 27 meters per second minus 0 meters per second over 2.5 seconds. It would be approximately 10.8 meters per second square, right? So writing this with two significant figures, it would be 11 meters per second square. So what is the magnitude of the acceleration? Is 11 meters per second square. Now, the second question here is how far had the car traveled when it reached, the 60 miles per hour? So how far, how did the car travel? Okay, when we have, or when it reached, the 60 miles per hour. Okay, so we have two different ways to calculate this. Okay, we can just use the equation of position, and we say, the position or the variation in position. You can say x equal x sub 0. You want to find variation in position because, or you can assume, that x sub 0 is 0, or you can just bring x sub 0 to the left and you say this is delta x, this is the displacement. It makes sense. This is a measure of how far the car have moved or have traveled in this interval of time, plus p sub 0 t plus 1 over 2a t squared, right? What happens? This x, if I bring x sub 0 to the left, as I said, this would be like a delta x, so it's the variation in position, is the distance that have traveled. But I know that b sub 0 is 0 because we are going from 0 to 27 meters per second. So b sub 0 is 0. So delta x is equal 1 over 2a t squared, right? Now, we know the acceleration is 11 meters per second squared. And we have the time, that is 2.5 seconds. So we say 2.5 seconds squared. And we can have, now the value of delta x, that would be 34 meters. So how far has the car traveled when it reached 60 miles per hour? It has traveled 34 meters. So now my car, I know that is 34 meters from the initial point, right? From the starting point. So this is, the simplest way to calculate now the position of the car once I know the acceleration and once I know the time, that took for the car to go from 0 to 27 meters per second. Okay. Any question? No questions?
No,
No
Professor.
questions,
When-
Professor.
When do you know which formula to use? Like, there
Right.
are three?
Yeah. Always base it on what information is available, right? Because, for example, let us see what happens if we try to calculate this same delta x using other information that is available there. I know that b final square is equal to b initial square plus 2a delta x. I have this other formula, that let me calculate what this delta x will be the distance traveled, right? The displacement, the change in position, right? So what happens? I know that this is 0, okay? Because the initial velocity was 0. We're going from 0 to 60 miles per hour, right? So we say, okay, this is BF squared. What is BF squared? We know that is 27 meters per second square equals 2 times, what is the acceleration? 11 meters per second square, times delta x. So we solve for delta x. This is 27 meters per second square divided by 2 times 11 meters per second square. This is delta x. So my delta x will be, if now I find 27 square, and I divide that by 22, sorry. This is 33 point something. I already round here, it would be greater because I already round this velocity to 11. If I use the original value that was 10.8, it would be a little bit greater, So it is approximately like 33.1, you say like a 33.1. If I use, instead of, this value, I use for this calculation, 10.8, this will be lower. If I use 10.8 here, this will be greater. So we get exactly the same numbers. Do you see